chapter 8-2, we're adding fractions and mixed numbers. Based on lesson 1, we learned how to do it using models, but I wanted to focus on the definition of a mixed number, and the definition of a mixed number is?
It's a number that is a sum of a whole number and a fraction.
Okay, so sum is a keyword, and then the other keyword was whole number and fraction, right? So in our example, we have here 1.5. So the 1 equals the whole part, and the half equals the fraction part, right? So adding here is the same thing. So the key word here is add, which means is another word for sum, right? When you're adding fractions or adding numbers together, you're finding the sum of that, okay? So today we're going to find out when we add mixed numbers that have common denominators or like denominators and unlike denominators. Okay, so Mrs. Chang, Brian.
Okay. Mrs. Chang spent 3.5 hours gardening on Saturday. She spends 2/3 hours working in her garden on Sunday. How many hours did Mrs. Chang spend gardening that weekend?
Okay, one more time, read the question for me.
How many?
Okay, so I'm finding how many hours, which is adding it all together. And then we're going to take 3.5 and add that to 2/3. But since they do not have the same denominator, I need to find the same denominator. Are they multiples of one another? No. So what do I need to do to the two denominators, Vedant? Oh, right, exactly. So if I multiply the denominators together, what do I get? Very good, 6. So 1/2 turns into how many 6? 3 6. And 2/3 changes into 4 6. Very good. So 3 6 plus 4 6 equals a total of 7 6. Now, do not forget the what? 3, the whole number, okay? It needs to come along for the ride, okay? So 3 and 7, 6. Now, is this in proper form?
Yes.
It is?
No.
I see a problem with this. I see that it is not in proper form. What is the problem with this, Aviv?
7 is greater than 6.
Right. The numerator is greater than the denominator. That is an improper fraction. It is not in simplest form. So, with that being 3 and 7, 6, we need to change the 7, 6 to a what? Mixed number. Right, exactly. So, I know that if I had a whole, one whole, this goes back to the last lesson, and I had 6, how many 6 equal a whole?
6.
Very good. 4, 5, 6. But how many 6 do I have? 7, right? That means there's one extra one out here beyond my whole. So that means, what do I need to do with my 1/6 here? I have one whole. This makes up one whole. And then I bring along the 1/6. So that gives me my mixed number, 1 and 1/6. Now, again, what can I not forget? What can I not leave behind? Tom? The 3, right. So now it becomes 3 plus my new 1 and 1/6. So I'm going to add the fractions first. Why should I add the fractions first and not the whole numbers first? Why is it important for me to add the fractions first? Mark?
Because if you add the whole first, because you need to add the fractions, so then you can find out if there's another mixed number or not.
Right. You might have another whole number to add on to the whole numbers, right? So in this case, is that the case? Does that apply? No, but that doesn't mean that you shouldn't add the fractions first, okay? So you want to add the fractions first, see if you come up with more than a whole again, because you want to add that to the wholes you already have. So here, we're adding 3 and 1/6. So 1/6 And then now I add the 3 and the 1, which is a 4. So how much time did she spend gardening all weekend? 4 and 1, 6 hours gardening
All weekend.
that weekend. Yep, all weekend.
I'm hungry.
Okay, and box your answer. Okay, this one's pretty easy because the fractions are already what? The same, right? They have the same denominator. So remember, again, you're going to add the fractions first. So what is 1/6 plus 1/6?
2, 6.
2/6, right? That equals.
1/3.
And then I add the whole number, which is 4. So I have 4 and 2/6. Is this in simplest form?
No.
No, it's not. The numerator and denominator can be divided by what?
2.
2. So 2 divided by 2 and 6 divided by 2 equals 1/3. So that equals 4 and 1/3. And that would be my answer. That was pretty easy because they have the same denominator. Okay? Let's try one where they don't have the same denominator, like number 5. Okay, number 5, we have 1/5 plus 1 and 1/4. So what, are they multiples of one another, 4 and 5? No, they're not. Okay, so we need to multiply those two together, 5 and 4, which gives us 20. So my new denominator is 20ths. So how many 1/5 is equal to how many 20ths? Times 4 times 4, so 4 20ths. And then times 5 times 5 equals 5 20ths. So now I can add 4 20ths plus 5 20ths, which gives me,
9 20th.
and then don't forget the 1. 1 and 9 20ths. Is 9 20ths in simplest form?
Yes.
Yes, it is. So then all I need to do is box it. Okay, so we have 9/12 plus 3 and 1/2. Do they have the same denominator?
No.
No. Are they multiples of one another?
Yes.
Yes. 2 can become 12ths, right? So 1/2 is equal to how many 12ths?
6.
6 12ths, half of it, right? Half of 12 is 6. Now can I add 9 12ths plus 6 12ths?
Yes.
Yes, I can. I have
13 12.
9 plus 6 is
15
12ths. Don't forget my what? 3, my whole number. 3 and 15 12ths. Now, if I don't want to do it the model way, which we learned in lesson 1, but I want to do it mathematically, okay? There's 2 different ways that you can do this, okay? The first method is you can use division, okay? So what you do is you take your numerator, which is 15, put on the inside, and take your denominator, which is 12, and you put it in the outside, which is your divisor, okay? Think of dividend, it ends, right? Divisor, what you're dividing by, okay? So how many times can 12 go into 15? Once, right? So 12 times 1 is 12. 15 minus 12 is 3. What does that 3 represent? The remainder, right? So that means I have 1 whole and 3 out of a possible 12 left over. Okay? So that's what that means. Okay, so you can use division to show how you figured this out. Now, is 3 12ths in simplest form? No. So then you would have to reduce even further and divide each side by 3 to get it in simplest form, which is 1 and 1/4. Okay? The second method that you could have used, okay, is subtraction. Now, this one is not always going to be the easiest one, But I could simply think of how many 12ths equal a whole. 12, right? Numerator over denominator always equals one whole when they're the same. When it's the same number, top and bottom, numerator, denominator, that always equals a whole. So if I know 12 12ths equals a whole, and I have 15 12ths, I'm going to take 15 minus 12, which equals 3. So that means I have 1 whole and 3 left over, giving me, again, 1 and 3/12, which I reduce down to 1 and 1/4. Okay? So, if I have 1 and 1/4, am I done yet? No, I simply changed 15 12ths into 1 and 1/4. I still have this 3 here. So my new problem now becomes 3 plus 1 and 1/4. So I add the fractions together first, which is 1/4. And then I add the whole numbers together, which is 4. And my answer is 4 and 1/4.